Simultaneous equations. All right, let's use a graph to solve the simultaneous equations here. X plus y equals 20 and x minus y equals 2. So we'll do this one graphically and then we'll do 3 algebraically. All right, to write these out as straight lines, we need to put them in the form that we're familiar with, which is y equals mx plus b. So that means we need to rearrange both of these first. I've graphed them here, but we'll just confirm that it's right. So to rearrange this one, we subtract x from each side, or just move the x over there. So we'll have y equals negative x plus 20. And that one you can see right here, 20 minus x, or negative x plus 20, same thing. And that means the intercept is 20, and there it is. And the slope is negative 1. So down 1 over 1, down 1 over 1, down 1 over 1. This equation will take a little more work to rearrange, so what we'll do is move the x over, so we'll have negative y equals negative x plus 2, and then multiply each side by negative 1. So if we do that, this becomes positive, and this value here becomes negative. So we're left with y equals x minus 2, y equals x minus 2, sorry. And that means the intercept is negative 2 right here, and then the slope is 1, so up 1 over 1. Okay, so when we use a graph to solve these equations, first we make them both into linear equations, and then we graph them, and wherever they intersect, well, that's the solution. So here we can see that both of these lines cross right here. The x value for that is 11, and that's been written here in the coordinate. So 11 is the solution, and we can check. So what does that mean exactly? It means they both have the same value for y when x is 11. So if you put 11 in here, negative 11 plus 20, that's 9. If you put 11 in here, 11 minus 2, that is also 9. So that is the solution. We just solved these simultaneous equations graphically. Now, algebraically, there are two methods, and the first one we're going to do is called rearranging, or substitution, sorry. So we're going to rearrange first, and then we're going to substitute. So to do that, we need to decide which one of these is going to be rearranged. Let's take the second one, because there's a little bit less numbers to rearrange. So what we'll do is say that x equals something. That's the substitution part. So if we write out this equation, the second equation, x plus y equals 18, what we're going to do is have just x. So we'll subtract y from each side. Okay, so y minus y, it's gone. So x equals 18 minus y. Now what we're going to do is substitute this part in here for x. Okay, so if x equals 18 minus y, according to the second equation, we'll put that into the first one. So we'll replace this x with this part right here. So the first equation is x plus 2y equals 29. But we've said that x equals 18 minus y. So we're going to put that in right here. Okay, so we're going to put this part in. So 18 minus y plus 2y equals 29. Now we have one equation with one unknown. Before we had two equations with two unknowns. Now we have one equation with one unknown, and we can rearrange and solve this. We can first group like terms, so negative y plus 2y will be y. So this yields 18 plus y equals 29. We want just y on the left side and just 18 on the right side, so we'll subtract the 18 from each side. And 18 minus 18 is gone. We have y equals 29 minus 18, which is 11. So we get a solution of y equals 11, and now we need to find x. Well, right here we said x equals 18 minus y. Actually, you can put it back into any of these equations. You can put it in here, you can put it in here, anywhere you want. Just substitute in y equals 11, but we'll stick with this one. So x equals 18 minus y. Y in this case is 11. So x equals 18 minus 11. That means we get 7. So this method is called substitution. And what we're going to do is two more problems, but we're going to try elimination instead. So elimination works by eliminating. Go figure. We're going to multiply one or both equations by a value so that we have either the same number in front of the x's or the same number in front of the y's. In general, I tend to just make the same number in front of the x's and just do the same thing, so it's always the same process. But you could eliminate the y's. So what do we want here? There's a 2 in front of the x here, and there's a 1, right? There's an invisible 1 times x is still x here. Well, that's not, I want them to have the same value. So if I call this equation 1 and call this equation 2, if I leave number 1 alone, that's fine. And then equation 2, I'm going to multiply by 2 so that I have a 2 in front here. But I have to multiply the whole thing. Okay, so I'm going to multiply equation 2 by 2. So 2 times x will give me 2x, and 2 times y will be plus 2y, and 2 times 11 will be 22. So all we've done is multiplied this second equation by 2. And the reason we did that is because the first equation has a 2 in front of the x. So if we now just bring that first equation down here, 2x plus 3y equals 28. We haven't done anything to it, we just rewrote it. Now, what we have are two equations where the value for in front of the x is the same. So we're going to subtract one from the other. We're going to subtract this whole equation from this entire equation. So 2x minus 2x, we'll do this term by term. 2x minus 2x, well, those are gone, and that was the whole point. That's how this elimination method works. Here we have 2y minus 3y, so that's a negative y. And here we have 22 minus 28, so that's a negative 6. So if we multiply each side by negative 1, we'll get y equals 6. And now we need to find out x, so we can sub in our solution for y back into this second equation here or this first equation here. Either one will give us the same answer. So let's put it back into the second equation just because there's a little bit less math to do. So what the second equation is x plus y equals 11. So we're going to put y equals 6 in here. So x plus 6 equals 11 because we found out that y equals 6. So we need to rearrange this equation. We will subtract 6 from each side. X equals 11 minus 6, which is 5. So we've decided, or we found, that y equals 6 and x equals 5. And so what are we saying here exactly? When x is 6 and y is 5, yes, indeed, this equation is 11. So that's true. But also here, the first equation, when x is 5, we get 2 times 5, that's 10. And when y is 6, we get 3 times 6, that's 18, and 10 plus 18 is 28. So these values make both of these equations true. Let's try another one here. Let's do the elimination method a second time. So again, or not again, but one of them has 2 in front of the x. That happens to be the second equation this time, and the first equation just has a 1. So what we'll do is we'll leave the second equation alone. We can write that one down first if we want. So 2x plus y equals 21. And then we're going to eliminate the x. So let's take the first equation, and multiply by 2 so that we have 2x. So if we do that, we have 2x. And then we multiply this by 2, so negative 4y, and 2 times 8 is 16. All right, now we're going to subtract this entire equation from this entire equation. So 2x minus 2x, it's gone. That's the elimination. Y minus negative 4y. You need to watch your signs here. So we have y minus a negative 4y. So we actually add, right? 2 minuses is an add, so that's 5y. And 21 minus 16, that's 5. So if we divide each side by 5, we'll get y equals 1. And now we can choose if we want to put it into the first equation or the second equation. Either one will give us the solution for x. Let's put it into the first equation. So we've got x minus 2y equals 8, and we've decided that y equals 1. So we will substitute, or we'll put 1 in there. So we have x minus 2 times 1, so if x minus 2 equals 8, so we'll add 2 on each side, so x equals 10. Now we can go back and confirm that this works. So what we have here is x minus 2y equals 8 in the first equation. So we're saying in the first equation, x minus 2y equals 8, x is 10, and y is 1. 10 minus 2 times 1, 10 minus 2 equals 8. That is true. In the second equation, 2x plus y equals 21. 2x plus y equals 21. Okay, so we're saying 2 times 10 plus 1 equals 21, and yes, that is also true.